Alright, here's assignment 10.1 from yesterday. So it says match the radical expression with a simplified form. You have the square root of 100. 100 is 10 times 10. So you would go the square root of 100 factors out 10 times 10. Since you already have a pair here, you don't have to factor out any further. So the square root of 100, the simplest form is 10, so that's C. Square root of 2 and square root of 5, the 2 cannot be factored, 5 cannot be factored, so you'd multiply them together. 2 times 5 is 10, but you wouldn't have a pair to come outside of the radical, so it's going to be like A right here. Square root of 27, if you factor that out, 3 times 9, and then 9 can keep going, 3 times 3. Now you have a pair of 3's, and you have a leftover 3. So you'd have a 3 that comes on the outside, and then you'd have that leftover one that would stay on the inside. So number 3 is going to be D. And then the last one, 3 squared of 9, that 9 can be factored. So if you got the 9 and factored it out, you'd have a pair of 3's. They would go outside with the 3 that was already on the outside of the square root. And then 3 times 3 is 9. There's no need for the square root sign. So that's going to be B right here. Next section, it says use a calculator. So really easy. If you have one of these, if you don't, you're going to have to find out for your phone how do you do square roots. So you can YouTube it, you can Google it, put your phone model, and try to go from there. But on my calculator, square root of 42, all I have to do is go second x squared, 42, press equals, and it gives me my answer, 6.5. Because that 8 makes the 4 go up. For the square root of 76, same thing, second x squared, and then I put in 76. That would be 8.7. The 1's not big enough to make it change, so it stays a 7. 8.7. And then on number 7, square root of 35, second x squared, 35. And I get 5.9 because that 1's not big enough to change the 9. Last one, square root of 11. Second x squared, put the 11. I get 3.3. Because that 1's not big enough to change it. For number 9, it says use the Pythagorean theorem to find the length of the hypotenuse in radical form. So these two are going to be my legs, the square root of 10 and the 5. C is going to be my hypotenuse. So it's going to be the square root of 10 squared and 5 squared equals C squared. Square root of 10 squared is 10 because the square root and the square cancel each other. 5 squared, 25 because 5 times 5. Add these two together, 10 and 25 is 35. And then you would square root it to find the C. So if you have the square root of 35 and you try to see if you can simplify it because we want radical form, you would factor this out. You can't factor any further than 5 times 7. And then 5 times 7 can't get factored any further. So that means that this is the simplified radical form, square root of 35. Number 10, you're going to do the same thing. So these two are your legs. C is your hypotenuse. So it'd be 6 squared, square root of 15 squared, and C squared. 6 squared is 6 times 6, 36. Square root of 15 squared, square root and square cancel. So that's 15. 36 and 15 is 30, 40, 50, 51. So C squared would be 51. And then C would be the square root of 51. 51 can be divided by 3. And it's 17. And 17 is a prime number. So if I tried to break this up and go 3 times 17, I still wouldn't have any pairs. So that means that square root of 51 is the simplified radical form. Number 11, same process. These two are the legs. Square root of 5 squared, square root of 2 squared, and then that C is your hypotenuse. So the square roots and squares will cancel each other. So this is now going to be 5 plus 2. 5 and 2 is 7. You got to square root it because you want C by itself. 7's a prime number, so you know that your final answer would be C as the square root of 7. Number 12, it says use Pythagorean theorem to find the length of the hypotenuse to the nearest tenth this time. So now we want to use the calculator to get a decimal. So 3 squared, 5 squared, C squared, 3 squared is 9, 5 squared is 25, 25 and 9 is 34. And then from here I need to use a calculator to get the square root. So second x squared, 34, and I get 5.8. So that would be the decimal answer for number 12. Number 13, the 4 and the 6 are your two legs. 4 squared is 16, 6 squared is 36. 36 and 16 is 52. Need to square root that. So the square root of 52 is 7.2. Number 14, 2 and 7 are the legs. So 7 squared, 2 squared, C squared. 7 squared is 49. 2 squared is 4. 49 and 4 is 53. And then square root of 53 is 7.3. Number 15 says multiply the radicals and simplify if possible. So you're not getting a decimal. Simplify means you need to try to factor it out and look for pairs. So 5 and 3, 5 cannot be factored, 3 cannot be factored, so you just multiply those together inside the radical. 5 times 3 is 15. That's all you can do. On number 16, 10 can get factored out. It's 5 times 2. And then now you have this 2 and this 2, so there's your pair. That's going to go on the outside of the radical sign, and then the 5 is going to stay inside. And then number 17, 5 is prime. This 5 is also prime, but because there's 2 of them, that's your pair inside the radical. So that's going to go outside with that 3 that was already there. So 3 times 5 is 15. There's nothing left in the radical, so you don't need the radical sign. And that's your final answer. Number 18 says simplify the radical expression some more. So this time you're not multiplying them, but you're still simplifying them. So you need to factor this out. 40 is 4 times 10. 4 is 2 times 2. 10 is 2 times 5. And then you're looking for a pair that goes outside as a single 2, and then these two don't have pairs, so you multiply those back together, and that would be your simplified radical expression. 50, same process, 2 times 25, and then 5 times 5. There's a pair of 5s here. There's this 2 that doesn't have a pair, so the 5s are going to come out as a single 5, and that lonely 2 stays on the inside. 75 is 3 times 25. 25 is 5 times 5. And then here's a pair right here. Goes on the outside. This 3 doesn't have a pair. It's all lonely. Stays on the inside. This says find the square root. Round your answer to the nearest tenth. Check that your answer is reasonable. So if you're just finding the square root, that's calculator work. I know it's going to be a little bigger than 8 because 64 would be, the square root of 64 would be 8. So square root 65. That rounds to 8.1. And then that makes sense because if I multiplied 8 times 8, it'd be 64. That's just a little bit bigger, so that's what it means by see if your answer is reasonable. 97, that's almost 100, so square root of 100 would have been 10. We're looking for something just a little bit smaller. Square root of 97, and we have 9.8, so that's reasonable. For 123, that's a little bigger than 121. The square root of 121 would have been 11, because 11 times 11 makes 121. So I'm looking for something a little bit bigger than 11. So square root 123, I get 11.1. So that's just barely bigger than 11. That's what I want. That's what I expect. And then 151 is a little bigger than 144, because 12 times 12 would be 144. So this is going to be a little bigger than 12. Square root 151, I get 12.3. Finding the length of the hypotenuse, so we're doing like we did on the back side. This time both of these are square rooted for here. So the square root of 46 plus the square root of 11 equals c squared. Sorry, the square root of 46 squared and the square root of 11 squared equals c squared. So this one's going to be just 46 plus 11 equals c squared. 46 and 61 is 57. I know that 57 is prime, so I don't have to keep going with it. It said radical form, so not a decimal, that's radical. This one, square root of 17 squared and 5 squared. Those are my legs. C is the hypotenuse. This 17 is just going to come out of the radical, but it's going to stay at 17. 5 squared is 5 times 5, so 25. 17 and 25 is 42. So 42 equals c squared. That means when I square root it. 42 factors out to be 7 and 6, and 6 is 3 and 2. And when I factor it out, there aren't any pairs. So that means this is still a simplified radical answer. And then the last one of these three, square root of 5 squared, 8 squared, c squared. The square root and the square cancel, so this one's 5. 8 squared is 8 times 8, 64. Add those together, you get 69, and then you square root it. So if I get 69, I can divide by 3, and that gives me 23. But 23 is a prime number, so there's no pairs. That means that my answer for C on number 7 is the square root of 69. Number 8, find the missing side length, round the answer to the nearest tenth. So now we're talking about nearest tenth. The 3 and the x are going to be your two legs. So it's going to be x squared and 3 squared together on one side of the Pythagorean theorem. Square root of 14 squared on the other side, that's your C value. The 3 squared is going to be 9. The square root of 14 squared is just going to get the 14 out of the square root. You need to subtract to move it across. So if you subtract 9 from 14, you get 5. And then you have to square root it. So your answer is the square root of 5. But since it says to the nearest tenth, got to follow directions. Square root of 5 is 2.2. So 2.2, that would be your final answer. Number 9, here's your two legs. That's your hypotenuse. So it would be x squared and square root of 7 squared equals square root of 10 squared. The 7 is going to get taken out of the radical, so it's just 7. Same thing with the 10, it's just 10. Subtract 7 from both sides, x squared equals 3. Then you would square root to get x by itself. So for this one, your answer is the square root of 3. And then for number 10, these two are your legs, that's your hypotenuse. X squared stays x squared. The 17 comes out of the radical. 5 squared is 5 times 5, 25. So you need to subtract 17 from 25. And then last step, you need to get rid of the square, so don't forget square root it. So the square root of 8 can get simplified, but since we're just doing decimals, we're just going to go second, x squared, put in that 8, and we get 2.8. Number 11 says evaluate. Evaluate is kind of like simplify. You do not give me a decimal. So if you see a squared here, it means you have 2 square root of 6 times another 2 square root of 6. If you get the 6's, we could factor them out, but we already have 2 of them, so we can just go, you know what, this one and this one go together. That 2 was already outside the radical. This 2 was already outside the radical. This pair of 6's goes outside the radical. And inside, there's nothing left. So you just multiply 2 times 2 is 4, and then 4 times 6 is 24, and that would be your final answer. Same thing here, 4 square root of 5 squared means 4 square root of 5 times another 4 square root of 5. So here's a pair of 5s, 4 times 4, outside, that 5, outside. There's nothing left inside of this radical, so you'd go 4 times 4 is 16, 16 times 5 is 80. That would be your answer. 13, same process. 3 square root of 2 times another 3 square root of 2. 3 times 3 is going to give you 9. Then this pair of 2's would come out as a single 2. So 9 times 2 is 18. There you go. Number 14 says simplify the radical expression. So factor it out. 54. I know it's even, so I can divide by 2. 27. And then 27 I can divide by 3 and I get 9, and 9 I can divide by 3 and I get 3. So I factored completely. And then I have a pair of 3's. I only have 1, 2, and another 3. So the pair of 3's comes outside as a single 3. 2 times 3 multiplies inside and becomes a 6. Number 15, 250. That 10 tells me I can divide it by 10. 10 is 2 times 5. 25 is 5 times 5. That means you have a pair of 5's that goes on the outside, and you have a single 2 and a single 5 multiplying back together on the inside. And then the last problem, 300. I can go 3 times 100, and 100 is 10 times 10. And I don't need to keep factoring this because I already see a pair, and that one's by itself and it's prime. So the 10 would go to the outside, the 3 would go on the inside, and my answer would be 10 square root of 3.